How's it going, accelerated chemistry students? This is Mr. Spurk, and these are your lecture notes over Chapter 9, Section 4, all over naming and writing formulas for acids and bases. So the names and formulas of acids. When naming an acid, you can consider the acid to consist of an anion combined with as many hydrogen ions as needed to make the molecule electrically neutral. So if you remember when we were making ions, we were adding up the net charges so that they were electrically zero or neutral. Therefore, the chemical formulas of acids are in the general form H subscript N, that's going to tell us how many H's we have, X, where X is a monatomic or polyatomic anion, and N is a subscript indicating the number of hydrogen ions that are combined with the anion. There are three rules that can help us name an acid with the general formula HNX dissolved in water. So the naming system depends on the name of the anion, or X, in particular the suffix of the anion name. So the ending, the suffix, is what's most important to us here. Each rule deals with an anion with different suffixes. So we have IDE ions, ITE, and ATE. So this is why we asked you to memorize 60 polyatomic and binary ions, because there are so many different names, and that's going to help us name the acids. So rule number 1. When the name of an anion ends in IDE, the acid name begins with the prefix hydro. The stem of the anion has the suffix -ic, or IC, and is followed by the word acid. So therefore, HCl, where X is chloride, is named hydrochloric acid. So you see that we kept chlor for chlorine, but we added a prefix and a suffix because chloride ion ends in IDE. Rule number 2. When the anion name ends in ITE, the acid name is the stem of the anion again, with the suffix us, OUS, followed by the word acid. So H2SO3, where our anion is the sulfite anion, SO3 2-, is named sulfurous acid. So ites go to us. And the last rule, rule number 3, when the anion name ends in -ate, the acid name is the stem of the anion with the suffix -ic, followed by the word acid. So HNO3, where our X is nitrate, we call this nitric acid. So the way that I like to remember the -ate and -ic endings is that you ate something and it was icky. So ates go to -ic. You ate something and it was icky. So here's just those three rules. They're just listed here in a table. You can see that when they end in IDE, such as chloride ion, we go to hydrochloric acid. The ite ending, sulfite, we call that sulfurous. And the ate endings go to -ic, so nitrate becomes nitric acid. So now we need to talk about writing the formulas of acids. So to write the formula for an acid, we use the rule for writing the name of the acid, but just in reverse. So then we're going to balance the ionic charges just as you would for any other ionic compound. So for hydrobromic acid, we see the prefix hydro and the suffix -ic, right? So we have hydro and -ic. And we can see that our stem is BROM, which is bromine. So we know that this is going to follow rule number 1 because of the hydro and the -ic. So since we know that our anion is bromine, which we know is called the bromide ion, we can write the formula for this by saying H plus, because all acids are going to have H plus, and our bromine ion is negatively charged. H plus, I know that plus looks pretty funky, but H plus and Br minus, and then just like we did when we were naming ions, we're going to crisscross those charges, and we're going to end with HBr, or hydrobromic acid. So let's try it for phosphorus acid. So phosphorus acid, you might notice that we have PHOSF, which might remind you of phosphate or the phosphite ions, that family. And it's an acid. So we know for sure that we're going to have an H plus, and we're going to have PO. And now here's where you guys need to know your ions. Since the ending of our acid is OUS, we're going to follow rule 2 because, and we know, or we should know, that ite endings go to us. So this is going to be PO3 minus phosphite. So we're going to crisscross those charges. Sorry guys, I just realized even I make mistakes. Of course, as you guys know, phosphite ion is PO3 3 minus, not just 1 minus. So we're going to crisscross our charges, a +1 and a 3 minus. And we are going to write the formula HPO H3PO3, phosphorus acid. So now we want to look at sulfuric acid. So here we see that we have an ic ending, and if you remember my little riddle or little saying, you ate something and it was icky. So we have sulfur, and we know that our anion had to end in ate. So we must have the sulfate anion, which is SO4 2 minus. That one is right this time. And we have H plus because we're an acid. So we crisscross our charges, and we end up with H2SO4, sulfuric acid. So there's many industrial processes, including steel and fertilizer manufacturing, that use acids, and you should become familiar with the names and formulas of some common acids, such as those listed over here at the right. So these are our most common acids that industry uses, and some of the most common that we will use here in this class. Most commonly, we're probably going to end up using just hydrochloric acid and sulfuric acid. So now that we talked about acids, we need to talk about bases. A base is generally an ionic compound that produces hydroxide ions when dissolved in water. And bases are named in the same way as other ionic compounds. The name of the cation is followed by the anion. So here we don't need to learn any new rules. This is just like naming ionic compounds. The common base sodium hydroxide is used in making cleaners, soap, and paper, as shown in the figure on the right. That's just a giant roll of paper. So sodium hydroxide is NaOH, is composed of sodium cations, Na+, and hydroxide anions, OH-. So to write the formula for a base, we first write the symbol for the metal cation, followed by the formula for the hydroxide ion. Then balance the ionic charges just as you would for any other ionic compound. So for aluminum hydroxide, we know that aluminum is Al, and it's in group 3A, so it's going to have a 3 plus charge. And our hydroxide anion is OH minus. So we're going to crisscross those charges, and we are going to end up with AlOH. And now remember, since we have more than one OH, and OH is a polyatomic ion, we need to keep it all together by adding in our parentheses 3. So now this says that we have 3 hydroxide anions. So AlOH3 is our formula for aluminum hydroxide. Bases are named just like other ionic compounds. Just like we had said on the previous slide, we name the cation followed by the anion. So here we have KOH, and we know that K is potassium, and OH is hydroxide. So it's just that easy as knowing your ions. Potassium hydroxide. And here we have FeOH2. So if you remember our little trick about uncrossing our charges, we're going to have Fe2 plus and OH minus when we uncrisscross. So when we name that, we have iron. And since iron is a transition metal and has more than one common charge, we need to put our Roman numeral, iron 2, hydroxide. Good news, this is the end of your Chapter 9, Section 4 notes, and as always, the information on these slides has been acquired and adapted from Pearson Chemistry 2012 edition of the textbook. Resources, CD, and pearsonchem.com. Thank you, and have a good night.